welcome to this second track of the day and the last track from today that is called Data Mining and Big Data Analysis. So it is a pleasure for me to be here presenting two amazing women that we will talk about her work and her experience in this area. So let's start with Patricia Ordoñez. She's an associate professor at the University of Puerto Rico. I am surprised because she is the first Latina or Latin American woman to graduate with a PhD from the Department of Computer Science and the College of Engineering and Information Technology at UMBC. She obtained her BA and MS and PhD in Johns Hopkins University and the University of Maryland, Baltimore County. And she's also the first woman promoted to be an associate professor in the computer science department at the University of Puerto Rico, Rio Piedras. And her talk is entitled I Can CS. So Patricia, when you want, you can start to share your screen.
Can you hear me?
Welcome. Yes.
Thank you. Gracias. I just want to make sure I have everything ready. Can you see this?
Yes, not in the full screen mode, but yes.
There we go.
Now, yes. Thank you.
So I call this I Can CS and change it to DS. And voy a comenzar un poquito en español para que sepan que sí hablo español. Fue mi primer idioma, pero ahora domino mejor el inglés. Y bueno, desde que estoy en Puerto Rico, domino el Spanglish. Entonces, a veces cambio de uno al otro sin darme cuenta. Entonces si comienzo a hablar en español, que me recuerden, so that I focus in English. But normally I do better in English with science. So I just want to tell you a little bit about my career path because it wasn't direct in any way. And I want to inspire those of you who are out there to get technical. Don't be scared of getting technical. So I basically started off at Johns Hopkins University, and I was actually trying to do it at 18. I had learned a programming language and I wanted to do something with programming. I went into electrical engineering and I got so intimidated I dropped off. And if you notice here, I say I became a teacher and I did technical support to get back into computing. I taught at these two schools, but there's kind of this black hole in my life where I couldn't figure out what to do. And, you know, the one thing that I always thought I would be is a mother and, a wife. And those two things didn't happen for me. So in this line right here is the year 2000. And so at that point, I went through, trips through Latin America. And I realized that there was computing everywhere. And even in the smallest little towns, I could find a computer cafe and I could see the potential of it. And so I made it my hobby at 34 that I was going to learn how to program. I managed to get a job at a training, etc., which was basically a place where people learned languages. And I basically told them, I will do the coordination of your classes if you teach me how to program. And I stayed with them. And the other thing I made them promise is that they would help me pay for school. And then so by 38, I went back to grad school at UMBC. So I want to show you these numbers because you're never too old if you have this passion in you. So at 34, everybody thought I was crazy that I was going to go back and to do the bachelor's. At 38, everybody thought I was crazy that I was going to do graduate student. At 40, I think I was 42 when I was applying for faculty positions. And again, it was like many people telling me I can't do it, that's crazy. And I'm just here to tell you that you can't listen to that. So two people that gave me really big predictions that I live by, and I say this to all of you, never believe a prediction that does not empower you. And so I did get a lot of people telling me, you're not going to be a programmer, you're not going to be a professor, you're not going to be, what else was it? Faculty, right? You're not going to get tenure, you're not in the right place. We get a lot of negativity. And so I wanted you to, if you ever have the chance to see Sean Stephenson and his life and career, he was told when he was young that he wouldn't live past his teens. And look at the wonderful life he lived. And then I also want to show you Grace Hopper, because the other thing that I thought was that women were not good at computer science because you never saw them anywhere and they never talk about them. But I am telling you here, as I've done more in computer science, women were critical in the development of computer science. And what happened is that when it became lucrative, they were basically pushed out. And there's lots of stuff out there that can show you that what I'm telling you is true. But I just want to show you one of the things that she did was create the first compiler. And what is really interesting is that as I've studied women, what they've done, they've constantly made computer science more accessible. And this is why we are so important in technology, because we have this to give, basically create things for our families and our neighbors and making things more accessible. And that's what I aim to do too with data science. So now let me go into why data science. I think the biggest this is actually Huracán Maria, and this is September 17th. This is right now I'm showing you this is an estimate of the rain precipitation. So no, this is a satellite. So here it's actually telling me a little bit about how much rain was falling down. And so I was just trying to show you that big data is everywhere. It's visualized. This can give us a lot of information, but to actually get into what's happening, we have to actually analyze the data. The other thing I wanted to show with visualization, though, with it, you can see here, I don't know if you can see my mouse, but you see how it decomposes, how like at the beginning, it was really tight, the circle, and then as it's coming closer, it falls apart. That shows you that it's slowing down. And these kinds of things can be predicted. Like you can see doing that with data if you wanted to. And because the other thing that happened is you'll see here, everything fell down, everything in Puerto Rico. This is actually the moment that all the electricity went out. And so moments like these, we have to start depending on things like satellites and data from above. Here is another one. This one's actually showing infrared, and it's basically an estimate for temperature. So you can see at that point how hot it was and how wet it was. Here is the other thing, that one was not actually, that storm, as big as it was not category 5, because to be category 5, it has to have 155 miles per hour in 1 minute. And before you saw that it went down, these were the numbers that it got. And because it was never sustained more than a minute. And so everybody on the island says it's the worst one they've ever hit, but it will never be categorized as category 5. And why do I tell you that's important? Because it was very easy for the US government to say that it wasn't as impactful as what hit other places. And so I'm here to show you how data can prove that wrong. I wanted you to get a sense of the devastation that happened here. So just 1 minute and watch this for a second. This is Rio Grande. Can you hear this?
Yes, we can.
Yes.
So this is the before and the after. So you can see exactly how much rain fell on Puerto Rico. And you can see the devastation. It's clear from above. This is the day after. Somebody had a drone this is the National Oceanic and Atmospheric Administration. They had a drone and they went and took pictures. They had pictures before, and this is the day after. Granted, there was no electricity. This is all on battery that was stored. And if you have the chance to go there, you can see the devastation. And I tell you, because anybody who would have looked at that should have known that Puerto Rico was in trouble. This is actually in the mountains of Puerto Rico. The mountains of Puerto Rico are very plush. Most people only see the rivers. And here you can see that, I mean, everything just got destroyed. Solar power systems, everything was gone. Over here, I'm also trying to show you some of the stuff that was basically here. What they're trying to show you is landslides. And if you notice, this was looking at the number of landslides per square kilometer. And in the red part, it says less than 25 per square kilometer. Then the dark red is more than 25 per square kilometer. Now, these numbers, because the people who are doing it should have been more than just 25, because let me show you what one landslide looks like. That completely isolated people in the island. Here's another. This is a river going across. Basically, the only mode of transportation was totally blocked. And so these people actually, what they had to do was actually fend for themselves. And that's one of the things that I wanted to say. The resilience of the Puerto Rican people during this time was amazing. And they helped themselves when people did not go help them. But with no data or false data, it was easy for the government to say that they were fine. I also want to show you some of the creative protests here that happened in Puerto Rico as a result of everything that was going on and as a result of Huracán Maria. And if you don't know, the governor was actually replaced for that. I also wanted to make, it's the very few times I get to talk about women in computer science. I just wanted to also point out that now there's, you know, the Supreme Court justices, they have her necklace there. And I just to remember that there are great women that are fighting for us to have rights. And she was one of them. And so we've just lost a great one. All right, let's go back to data science. So data science before used to be thought of as a T-shape where you had to have specific domain and then everybody cooperated, but now it's more interconnected. And so you basically have to have not only domain specialty, but some statistics and computing and depth in those fields. I wanted to introduce you to the people that are helping us do it because you can do this too. This is in a global community. It's called Data Carpentries, and these are the people that we've brought to Puerto Rico to help us train everybody in data science and how to program in R and doing informal education. Because right now we don't have the money to actually, you know, build the careers, but this is so basically train the professors to come. And with the way Puerto Rico is right now, it's really hard to bring people. And so I also wanted to make a plug for a book that just came out that I was an editor, and a chapter that I wrote in that explains everything that we did to promote a data science program in Puerto Rico. But this is really a talk about the importance of good data and scientific communication. And I'm trying to show how having that good data and having, you know, people who cared about Puerto Rico made it possible. And I also wanted to show women that were critical in this. And so there was a woman called Dr. Bucky who was doing, she's a psychologist who basically was at Harvard, and she was doing research in Puerto Rico, and she couldn't reach any of her friends. And so she contacts Dr. Irizarry, who is, you know, biostatistician, top notch from Puerto Rico. And she basically says, hey, I'm not able to reach my colleagues, do you know anything in Puerto Rico? He's saying that everybody's saying that the number is not correct that they were saying, because actually they said the official death count was 16 and everybody in his family was telling him no. And basically they started publishing to basically do an estimate of how many people had done this in November. And still they were trying to convince him, but he was scared, you know, he doesn't want people to see him as biased. He knew this would have to be a major work. But basically after he saw those publications, he actually scraped the data. He couldn't get the data, even though he kept requesting it. And what happened is that when he saw the data, he automatically knew that something was wrong. So he plotted basically all the mortality data from 2010 to 2016. And then when he looked at September and October, he knew there was no possible way that 16 was the official count. And then finally, he found, you know, New York Times had an estimate of 1,000. And so he basically got the data in a PDF and scraped it. And then he started comparing that data. And what was obvious to him, and what I still find incredible, is that New York Times didn't see this. Like, there's obviously missing data in the data that they received from the government, because it's actually saying it was lower death rate in December, abnormally lower, like significantly lower than what you normally would have. Almost no mortality. And then also in February 28th, the Puerto Rico Institute of Statistics also showed it, you know, had data. And again, you can see that there's missing data. But what I'm trying to tell you here is that, like, one plot, people who are publishing about this just get the data and plot it and get the results, but don't mention that there's missing data. So the importance of having somebody that really cares about Puerto Rico and was analyzing this data to continue to question the government was critical. So what did they do? They basically estimated the death toll, because since they couldn't get the data, they basically started doing a survey. They interviewed about 3,000 families to estimate the death count, and took the percentage of deaths times the population estimate. That required interdisciplinary collaboration. And so what they did was collaborate with the Universidad de Carlos Albizu in Viejo San Juan with the Professor Dominguez Marquez, who was psychology. And basically he had his students already out there doing interviews for the health and the mental health of the health and the mental health of all the families that were now suffering after Huracán Maria, in the largest and the longest, you know, blackout in history. And that's how they were able to move so quickly on this survey. And so what did they do? They created a model that took into consideration the increase of mortality, seasonal effects, and population estimate. And then they compared that rate of mortality that they got from that to the past years. And so what happened? And on the death toll was 64, right? They actually changed it to May 29th. Then that same day, the Harvard team publishes an estimate of 5,000 and approximately a little bit less than like 4,006. I'll show you the numbers in the New England Journal of Medicine. The next day or 2 days later, the governor of Puerto Rico is interviewed in CNN by Anderson Cooper. And he actually says, why isn't the data public? And that's how Puerto Rico was able to get the data public. So this number is really important. And one of the things I also wanted to show you was the importance of collaboration and interdisciplinary collaboration. You have people in public health, you have people in psychology, you have PhDs, you have BAs, you have MDs. And you needed all these people so that people would listen to this. And so I just can't emphasize enough the importance of inter-university collaborations, interdisciplinary collaborations to do good data science. And this is what it resulted. That number in this protesta, a third of the population ended up protesting, but it was actually after a release of chats where the governor was actually mocking the number of people in the morgue, and it was evident that he knew that he had been lying to the public. And this is what that led to. And it eventually was 2 weeks of creative protesting that I showed you before that led to him having to actually resign. So now that he had more data, Rafael Grisardi didn't stop at that. And this is also the reason we need advocates. All of our communities need advocates, right? Any population needs advocates. And this is where I'm saying data science is so important for everybody. Because once you have data, more data, so now here we have many years of data, and you can see how long this lasted and how unusual this is. Whereas when you look at it here, it might not be so much because this is like this little dip right here. So just to show you that more data makes everything more obvious. So after they did that analysis, they reduced their estimate to 3,000. But what's really sad is that didn't come out in Puerto Rico until like it was March. And that actually, the study was, like I mentioned, in June. It was March of the following year. So after he obtained the data, the next thing that he did was actually compare the mortality rate of Hurricane Maria to other storms, because the government in the US was actually saying it wasn't as bad in Puerto Rico as it was in Florida or these other islands. And so the government was basically using that data to justify not having to pay Puerto Rico the amount of aid that they deserved. And so I just want to show you that everything that he did is also reproducible, which is really important concept in data science, which I think all of you guys know. He made it public so that nobody could question it. They could run it themselves. And that was really, really important. And if you want to do this, it's great. I do this with my students. But I think no matter where you are, there are going to be topics like this that you can do with your students. And so doing a project that's culturally relevant, I think really engages them. The other thing that this does, if I have them reproduce that code, so reproducing means running the code using the data and the research techniques and arriving at the same conclusion, and making it replicable means that they can take that and apply it to other pieces of data. And so that's what he did in the second part. He took what he did, and he didn't. It's kind of weird because I'm talking about it that he's doing it to his own data, but he repeated what he did in that first experiment with the other ones to prove the point that actually, Puerto Rico, actually even comparing to any other of the big hurricanes, was significantly, different, and that so many more deaths happened after September. And then he showed again in Georgia's was the same thing. So you can see that these are all these different places, kind of looking at the percent change in mortality, right? And you can see that over here we have Hurricane Katrina that had a big percent change immediately, but then it still falls into the normal ranges afterwards. So he basically was trying to prove that it really did have a big effect in Puerto Rico. And here was I love this plot in particular, because not only is he showing his estimate, but he's showing the confidence interval, which I think is also something that we need to start, plotting more. And so therefore you can see it's very clear here how long Maria lasted over other ones, and he can actually show that it's more severe than Katrina and Georges and Hugo, and therefore here's representations of data. But again, this didn't hit and make the big noise that the first one did because it got to national television. All right, so this is really another thing that was really exciting, is that one of our students from UPR Humacao actually worked with him on this. And so this is also the thing that I kind of say, that you can empower so many of your students. Humacao is probably one of the poorest regions in the island. It was one that was hit the hardest. And so having, you know, Rolando Acosta, who was personally hit with this, be able to do this and print this, I think, and go to Harvard and study with this was really wonderful. In the end, I think what all this tells us is the importance of having good data. We need to have data that is findable. These are the fair data principles that are very important in anything that we talk about with data science. We want it to be findable, meaning that it has a unique identifier. That identifier could be a website where you have it, you know, a URL. It needs to be accessible so that anybody could access the data, and interoperable, so once they access it, they can actually use it between systems, like a very common language that could take it from a programming language that could take it from one, you know, system to another. And then again, it has to be reusable so that you're able to actually reproduce it. And so I have a link here for what are fair data principles. In the end, what I'm trying to tell you, that CS para todos, right? Computer science is for everybody, but not just computer science, DS also, because DS can empower communities that have been left behind. And I say this in the sense of Puerto Rico during this hurricane was just very much left behind. And it was the first time I saw the power of data science in real life. I wanted to acknowledge the people that I mentioned here for the work that they've done. All the videos and all that was given to me by Carlos Anselmi at the NOAA, and of course, Rafael Rizarri. I based this on his work, and Rolando Acosta also. So thank you, and let's meet for PR in Puerto Rico for the second WBS. Oh my gosh, and there's Puerto Rico for you. And if you want to reach me, or I'm available through Twitter or through email, although Twitter, fewer people reach me through Twitter, but I do get back to you. And that's all. I think I made it. Yay.
Yeah, it's perfect. Thank you so much. Your talk, I think that it was really inspiring for us, and it was amazing because you cover a lot of different topics about the data science and computer science in your minutes. So thank you so much for your presentation. I am checking if somebody have any question. You have a lot of congratulations in the chat room, so you can then check. I
have a question, Patty.
Of course.
Yes.
Can I, Gaby?
Yes, of course.
Yeah, thank you for your talk. It was amazing, really. And I would like you to tell us how do we start? Because it's a common question, you know, when you are coming from, maybe not from science or not for, I don't know, for this kind of discipline. So how can we start, or the people start, the women here?
Mm-hmm. So one of the things that so you might think this is crazy, but I tell my students, you know, start like most people start. I think what happens is that you go to, you know, computer science or one of these data science courses, and they jump right in. And some of that is not so intuitive, and they expect you to know certain things. So if you can get a data carpentries class to come, that would be great. If you really don't have a place where you can get a data carpentries class, that is really, it starts basic, but it starts with science. So data carpentries is the science part. There's another one called software carpentry that is just about programming. There are so many things online right now. So one of the things that I use a lot is Data Camp for data science, and I use Codecademy for programming for my students. And now you also have, I think, if you don't even have, all you have is a web browser, you can do, let me put these all in here. Let me write these all. Codecademy. codecademy.org, I think it is. The other one that I said was for data science is datacamp.com if you have some experience. But you can start from nothing with DataCamp. It's just that it'll take you, it might be a little overwhelming. The one that I start my students that have no experience whatsoever, I start them with a book that was actually written for children, where you start just building little games on the command line, and it teaches you how to work with the command line. And that's Invent with Python. I love Python as a teaching language. Invent with Python, I think it's .com. And then the other one is the other ones that I recommend. I said Codecademy, Invent with Replit. If you do not have like all you have is a web browser and you can't install anything, Replit actually is really good because it has all these programming languages and they're starting to teach people. So before they didn't teach people, it was just a way for you to be able to run programming languages in their environment. And so Replit has been really good at now starting, because of all of COVID, people are starting to teach. And so that's another really good one. But I would even start it with your kids. So one of the things that I'm going to be doing is trying to promote this thing called Family Code Night. And we're going to do it in Puerto Rico in December. If any of you guys are interested in starting it, we're going to be trying to promote it to get people. Oh, Mumuki for Python also. I love, there's so many things. And I'm sure there are many more things in Spanish too, but I don't know the Spanish ones. In Puerto Rico, everybody uses the English one. Even though they all speak Spanish, they still use the English. They're very bilingual that way. But Family Code Night will be really fun because we're going to do it in Spanish desde Puerto Rico. So I'm going to start doing a podcast at CIDLA. I don't know if you've heard of CIDLA. Es el Centro de Innovación Digital en Latinoamérica. So Centro de Innovación. En América Latina, no, en Latinoamérica creo que es Latinoamérica, porque es CIDLA, Latinoamérica. America. And from there, I'm going to be doing a podcast to try and get all of Latin America to do first Family Code Night. And we're going to be trying to Mexico has already done one. And we were part of the one con Mexico. And it was wonderful. One of our teachers actually participated. And we got people just to code with their kids. And that's the first step. If you can get your kids excited about it, then you get more motivated. And if you don't have kids, you just do it with your kid, do it with your niece or your nephew. But we got to tenemos que incorporar a los nenes, porque if they get excited, you get excited. And if you can see them doing it, then you know you can do it, right? And so the thing is that what happened before is that there have been people who have been learning since they were little. And so then when you get up and compete with them, you're lost. Yes, WBDS can help. We're going to make it happen. Yeah. And the other thing that I don't know if you know that Stanford does a women in data science. And so they have something that you guys should actually do where they try to get everybody in March 2nd to do a data science conference for women. And because they're really trying to push data science. So that's another thing that we could all do together. Is to get more women in data science. But that one right there is like what you have. I've been so impressed with all the technical presentations that have been done today. Phenomenal. En mi vida he visto mujeres en cómputos y hoy estoy feliz. de ver toda la informática y todo lo que están haciendo. So let me just tell you that everything that you're doing in bioinformatics y todo eso, yo lo veo, and the majority of it, yo no sé la biología, right? Yo soy técnica, entonces yo tengo que aprender lo de lo técnico. Entonces cuando yo veo lo que ustedes están haciendo, yo digo, wow, qué maravilla. Mientras que ustedes también ven y wow, ella programa, ella hace todo eso. Es simplemente que son, I'm sorry, I'm speaking in Spanish again. They're different, right? And you just have to train. You just have to train, como todo, like everything. If you want to learn to play an instrument, you just have to start small. You have to walk before you can run. And so
And I
even
think
though
that
people talk
this
to
is
me,
a
huh?
this is a nice part. I think that this is a nice part of our area because it's very interdisciplinary, so we can find a lot of different disciplines
Exactly.
involved in the work.
Right.
So,
That's why we joined here. That's why this conference is trying to join those disciplines that are so similar, because we are all doing almost the same, but with cells or data coming from, I don't know, population. So it's kind of the same, but applied to another systems. So.
Or we are involved in several steps of the same problem. So because maybe we are some of us are generating the data, some other are analyzing the data. So
not just generating, cleaning is a whole different step. Like cleaning takes forever.
Yes. Yes, of course. So I should say thank you so much for your presentation and for all the resources that you provided us.